Hello and welcome to section 3, and this is a very important video about trigonometric ratios, okay? And what we're going to be able to do today, we're going to be given an acute angle of a right triangle labeled the hypotenuse, the opposite, and adjacent sides. Given the acute angle of a right triangle, write the ratios for sine, cosine, and tangent, and then relate trigonometric ratios of similar triangles and acute angles of a right triangle. So let's kind of just jump right in here. Trigonometry is kind of the study of right triangles, is kind of how I think of it. And using right triangles to basically find other measures of a triangle. Okay, so let's go ahead here and let's talk about the first thing real quick. Is labeling the sides of right triangles. Okay, now what I have here in a right triangle, okay, the first thing I have is this longest side called the hypotenuse, okay? And I'm going to come in here and always label this that the hypotenuse is the longest side, okay, is my longest side, all right? And it is always across from the right angle. So across from, and I may have spelled that wrong, the right angle, okay? So it's always this long side, and it's always across from your right angle here, okay? Now, these are legs, okay? The legs, Lieutenant Dan's magic legs of the right triangle, okay? And they are the sides that create the right angle. So the legs, I'm going to write over here, the legs create the right angle. Okay. Now, what I have here, given this triangle here, and I'm going to draw this a couple more times, I want for us to look at angle A. Okay. So given angle A here, okay, so angle A, looking at angle A, what I want to do is I want to identify, the other side lengths of this triangle, okay? And so what I have here is, given angle A, if this is my hypotenuse, the side that creates the angle of A and the hypotenuse, this side right here, we're going to call the adjacent side. So this is my adjacent leg. Okay, given angle A, okay? And then, if I wanted to name the other side here, this is the side that's opposite angle A. So over here, I'm going to write that it's my opposite side, okay? Now, the thing of it is, guys, is that given a right triangle and any angle in that right triangle, either angle A or B, we will have to be able to label the sides of this right triangle, okay? Now, this one's always going to be the hypotenuse, okay? But given that we're talking about angle A down here, we're going to call this side the adjacent side, okay? Adjacent means next to, and then the opposite side is the side that's not touching angle A, okay? Now, real quick, what I'm going to do is I'm going to redraw this triangle over here. Okay, I'm going to draw the same thing. Okay, call this a right angle. I'm going to call this my hypotenuse, call this angle A, angle B, and angle C. Okay, now this is always going to be the hypotenuse, all right? But I'm going to look at angle B on this one, okay? And given angle B, what I want you to notice is that all of a sudden, everything switches, okay? This side right here is a side that I'm going to call my adjacent side. My adjacent side. Okay, because it's next to angle B, all right? Now, on this side here is going to be my opposite side, okay? And that's how we do that, okay? So notice here, okay, in this triangle we were talking about angle A. This is always going to be the hypotenuse. This is my opposite side. This is my adjacent side given angle A. Over here, talking about angle B, okay, we were talking about this is my opposite side and this is my adjacent side, okay? All right, so now what I want to do here real quick is talk about my trigonometric ratios, okay? And we have three basic trigonometric functions for the acute angles of a right triangle, and they are called sine, cosine, and tangent, okay? And each function relates a given angle measure to a particular ratio of side lengths. So on each of these, what I'm going to do is I'm going to label, I'm going to go through each of these ratios, sine, cosine, and tangent for each of these, and we're going to look at the same triangle, okay? And all I did was basically copy the same triangle, and we're going to write the different ratios for each one, okay? Now we're going to do this for angle A, okay? We're going to look at one angle first, and then we'll look at angle B in the next one. Okay, so the first thing I want to do is I'm going to look at angle A. Okay, so for all these, I'm going to put my little arc mark here to identify my angle. Okay, so here's that angle A, and then angle A. All right, now what I'm going to do is, given angle A, I'm going to label this triangle, okay, and I'm going to label it the same. Okay, so I'm going to label this my hypotenuse, and I'm going to label this side my adjacent side, ADJ, and then this is my opposite side. Okay, I'm going to do that for all of them real quick. Okay, call this my hypotenuse, call this my opposite side, call this my adjacent side. All right, and so then call this my hypotenuse one more time, the opposite side, and the adjacent side. And I use my abbreviations like that, okay? So what I'm going to do now is I'm going to come in here, and I'm going to do this. I'm going to talk about what we call sine, the trigonometric function sine, okay? And so what I would do is I would say this, all right? I'm going to say sine of angle A is equal to the opposite side, this opposite length, divided by the hypotenuse, okay? All right, if you wanted to, and I'm going to write that down, okay? That's always going to be your sine value. Now, in this case, given something like this, what we would do is we would take sine of A, all right, and I would label that as the length of BC, my opposite side, okay? So the length of BC divided by the length of AB. Okay, and that's that, okay? So what I want you to see here is that when I do sine of angle A, okay, it gives you a ratio of side lengths, okay? So this is a ratio. This is going to be a fraction, okay? This is my ratio, okay, which is equal to saying sine of A, okay? A ratio is a number, So when I write sine of A, now I'm not multiplying anything, okay? Sine of A is a number, okay, is a number, all right? And we'll have a chance to look over all this, but right now I just want to go over what these are, all right? So that's sine of A. All right, now let's go ahead and take a look over here, and let's write cosine, okay? So this is let me write this up here, that this is sine, okay? In this example, I'll talk about that this is cosine, okay? Now for cosine, what I want to do is I would use the abbreviation COS, okay? I'm just going to call it cosine, and I would do of angle A, okay? And that would be equal to my adjacent side, okay? Let me do this. Let me get it so we can see it. This would be my adjacent side divided by my hypotenuse, okay? So my adjacent side divided by my hypotenuse, all right? Okay, and if I were to actually kind of, make sure I had values for this, all right, if I had cosine of A, all right, I would take segment length AC, okay, my adjacent length, and then I would divide that by my hypotenuse length, which is AB, okay? And that's that. Okay, remember, this is just a ratio. We're just writing numbers, all right? Now, the last one we want to talk about is tangent. Okay, is tangent. Okay, and for tangent, I use the abbreviation tan. Okay, so I would say tangent. All right, now if I took tangent of angle A, all right, then what I would get is I would get my opposite side divided by my adjacent side. So I'm going to come over here and I'm going to write that this is my opposite side divided by my adjacent side. All right? And so if I wanted to get technical here, I would say tangent of A would be the length of BC, okay, divided by my hypotenuse, or I'm sorry, my adjacent side, which is AC. Okay? So there's a pattern to this, all right? And so this is always going to be the case, all right? Especially for, looking at, say, angle A. Now let's look at angle B, okay? Let's switch this up and let's look at angle B. And I'm going to come in here and I'm going to label this. This is my angle B, okay? And I'm going to do that for all of my angle B's, okay? So now, when I've done that, okay, I'm going to come over here, and for angle B, I'm going to write that this is my hypotenuse, okay? And given angle B, my legs change, okay? This leg right here is my opposite leg, okay, is my opposite side, okay? And then this one over here is going to be my adjacent side, all right, next to. All right, I'm going to do that for all of them. So looking at angle B, this is always going to be my hypotenuse. Okay, this is my adjacent side. This is my opposite side. Okay, same thing over here. This is my hypotenuse. This is my adjacent side to angle B, and this is my opposite side. Okay, so what I'm going to do is I'm going to write out all the different trig functions for angle B. Okay, so now this is going to be, I'm going to call this one sine. Okay, so if I did sine of B, okay, so sine of angle B, all right, that would still be my opposite side, just like we had on the other one, divided by my hypotenuse, okay? And so if we were to get technical here, let's go ahead and do that. Let's do sine of B would be my opposite side, which would be AC, divided by AB, okay? Okay, and that's just doing it around angle B, okay, different angle. All right, so now let's go ahead and do that for cosine. Okay, so here's cosine. Okay, and if I went and did cosine of B, then that would be my adjacent side. Okay, this side divided by my hypotenuse. Okay, so I'm going to do my adjacent side divided by my hypotenuse. All right. So then if I did cosine of B, if we wanted to write out the actual values, that would be the length of BC divided by the length of AB. Okay. Okay, so now let's do tangent. Okay, and tangent is let's do tangent of B. Okay, and tangent of B is going to be the opposite side divided by the adjacent side. Okay, so now if I were to get technical and actually write these sides out, I would say tangent of B is equal to my opposite side, which is AC, divided by my adjacent side, which is BC. Okay, so now maybe you notice a pattern here, okay, that whenever I write these out, okay, I kind of already know what to do. All right, now before I do anything, let's talk about something here for a second. The question is you're probably sitting there going, okay, what in the crap are you talking about? Okay, I understand. Okay, this is confusing, this is hard, but again, it'll all make kind of sense when we do this. The reason why I had you guys write everything out is because I want you to at least have it written out. Okay, number one. Number two, the way I had you write it out, sine of A, there was a pattern to this, okay, and I wrote this out every time. I wrote sine was opposite over hypotenuse, okay, I wrote that out over here. Cosine was adjacent side divided by the hypotenuse, wrote that out over here, okay. Same thing with tangent, was opposite over adjacent, and over here it was opposite over adjacent. So you're probably sitting there going, okay, hey, wait a second, how do you remember this? How do you know this? And there's a trick, okay. Now what I want to show you is this, okay. And let me kind of change up colors here for a second. And so what I have here is I have this kind of a little bit of an acronym. Now we're talking about sine. Every single time you talk about sine of an angle, you're going to take the opposite side So when I talk about sine that starts with an S, you have the opposite side divided by the hypotenuse. And so you have the letters S, O, and H, okay? And so I get this phrase down here that I'm going to call so, okay? And then, all right, when I talk about cosine, okay, I'm kind of doing a similar thing. I use the letters that I have, and it begins with a C, an A, and then an H. And that we're going to call Ca, C-A-H. So Ca. All right? And then, over here, on tangent, you've got the letters T, you have O, and A. So you get the word toa. So the easy way to remember this is the phrase so ka toa. And, you know, I often will say that anytime I'm doing any sort of trig thing, even now that I've been doing it for 15 years, I still say so ka toa. And it almost kind of sounds like, I don't know, some sort of, tribal chant, around a fire, the so ka toa, so ka toa. And that's how I remember it. So as long as you remember so ka toa, trig really isn't that bad. Okay, so number one, draw your picture, draw your right triangle, okay? Label your right triangle depending on what angle you're using. And if you're being asked to find sine, cosine, or tangent, just remember so ka toa. And it's a lot easier. Okay, so on the next page, I'll go into how you use so ka toa to solve some problems. Okay, so now that we've gone through all that stuff, let's go ahead and kind of see how all of this applies. So what I want to do is calculate the trigonometric ratios. Okay, so on this one it says determine the value of sine of B for triangle ABC. So what I want to do, first thing I want to do is write out what we had written on the previous page, and that was so ka toa. Okay, don't ever forget that. If there's one thing you need to remember from geometry class, you will remember not only that Pythagoras is Mr. Police's friend, but you will remember so ka toa. All right, so if we look over here, we want to find sine of B. Okay, now what I do is I look over here and I say, okay, this is sine of B, and I'm going to look at that angle, and then I'm going to label my sides. And I'm going to label this long side, okay, always the one that's across from my right angle, as my hypotenuse. And I'm just going to call it H for right now, okay? And then I'm going to then also call this side over here my opposite side, okay? So I'm going to put an O there. And then this side right here, I'm going to call my adjacent side. So I'm going to put an A. Okay. So if I want to find sine of B, okay, so if I wanted to find sine of angle B, all right, then what I'm going to do is I'm going to take this side, this opposite side, okay, remember, and I'm just going to write this out real quick, that this is my opposite side divided by my hypotenuse, okay? It's okay to write that. I always write that just so I know that I'm doing it right, okay? Now what I'm going to do is, I'm going to write sine of B, okay? Sine of B is really just sine, B is a 30-degree angle, okay? So sine of 30 degrees, this part right here is your angle measure, okay? Now I am not multiplying this, okay? I'm not taking sin times 30. Okay, I am saying that I'm going to take the ratio of side lengths of a 30-degree angle using the sine function. So what that means is I'm going to take my opposite side, which is 10. Okay, so sine of 30 degrees in this case would be 10 divided by the length of my hypotenuse, which is 20. Okay? So then you can go on and you can say, all right, well, then sine of 30 degrees here would be equal to 1/2. All right? And that's what I know. Okay, now let's think about this for a second. All right, let's think about sine of 30 degrees equals 1/2. Okay? What is 1/2? 1/2 is the ratio of side lengths. Okay? It took the opposite side divided by the hypotenuse. And what that did is it gave me a number. Okay? 1/2 is a number. Okay? When I say sine of 30 degrees, that means I'm referring to a ratio of side lengths. This, when I write this, is a number. Okay? Simple as that. The trick is writing it and coming up with it and remembering what your ratios are. But remember, that's easy because you know what SOHCAHTOA is, correct? All right. So that's the idea. Okay? So the one thing I want to talk about real quick is this. It says the sine and cosine are called cofunctions, okay? And that is, they are functions that have equal output values, ratios of side lengths, where their input values, angle measures, are complementary angles. So what I want to show you real quick is let's do sine of 30, okay? And remember, we've already done this, okay? So if I talk about, let me do this, okay? I'm going to do sine in red, okay? I'm going to do sine of 30 degrees, okay? And then I'm also going to calculate cosine of 60 degrees, okay? So I got two different things going here, okay? I'm going to do sine in red, I'm going to do cosine in blue. All right, so if I come over here and look at my 30-degree angle, okay, then this is going to be my hypotenuse, always. This is my opposite side, and this is my adjacent side, okay? So if I do sine of 30 degrees, sine of E, sine of 30 degrees, okay, then what's going to happen is I'm going to take my opposite side, which is 2, and divide it by this hypotenuse, which is 4. Wait a second. Huh. So if I do sine of 30 degrees, okay, that's going to simplify down to 1/2. Wait, wasn't that the same thing we got up here? Yeah, it was. Okay, and the reason why is because these triangles are similar. Okay, this is a 30, 60, 90 triangle, same as down here. This is a 30, 60, 90 triangle. So if I have any triangle, any right triangle with a 30-degree angle, okay, and I take sine of that 30 degrees, I'm always going to get 1/2. It's always going to be the same. So these functions kind of give you, write out your similarity ratios, okay, and that's kind of the point of it, all right? There's other applications to it, and we'll get to that eventually, but for right now, that's the idea, okay? So now, all right, now over here, let's do the same thing, but let's do it for cosine of 60 degrees, okay? Now, these kind of change up a little bit, all right? This, given this is my 60-degree angle, now this is my opposite side, and this is my adjacent side, and now I have my hypotenuse. Okay, now remember, because we know what SOHCAHTOA is. Because we are using cosine, I have to use this. I have to use ka, and that's my adjacent side divided by my hypotenuse. So I'll come over here, and given my cosine of 60 degrees, okay, then I'm going to write this out. So I'm going to do cosine of 60 degrees, and that's going to equal my adjacent side, okay, which is 2, divided by my hypotenuse, which is 4. So I get the same thing, okay? So I would take this as 2 divided by 4, and I would write it down here and say cosine of 60 degrees is equal to 1/2, okay? So what I know is that we get the same thing, 1/2 here and here. Okay, again, when I write out these ratios, when I write out these trig functions, these are numbers, okay? And so the thing that I have to realize is that if sine and cosine are what we call cofunctions. And if I take the sine of a number, of an angle, and then take cosine of its complement, okay, 30 and 60 will add up to 90 degrees, then these two values are equal. Okay, and that's the idea behind cofunctions. Okay. All right, so let's go ahead and let's take a look real quick. Let's determine the sine and cosine trig ratios of this given triangle, okay? Now, what I have here is I don't really know what these sides are. They're x, and x times the square root of 2. Okay, this is any trig ratio for any 45, 45, 90 triangle. Okay, so what's going to happen is this, all right? Let me just go ahead and do cosine of 45 degrees, okay? And I'm just going to go ahead and use this angle here. Doesn't matter. I could use this one down here at the same angle. Doesn't matter. Okay, but just because, let's do this. Let's write out our hypotenuse. This is my opposite side, and this is my adjacent side, given this 45-degree angle here. So what I would do is I would say, all right, well, I'm going to take cosine of 45 degrees. That's this length A, okay, my adjacent side, which is x. So this is equal to x divided by the hypotenuse, which is x times the square root of 2. Okay, so this is x times the square root of 2. Okay. Now, I'm going to do the same thing for, well, before we do that, let's go ahead and just simplify this, okay? Cosine of 45 degrees, I'm going to rewrite that. Cosine of 45 degrees is equal to, what happens here is now I have x divided by x. Those divide out, okay? And you're left with 1 over the square root of 2, okay? Now, we don't like having the square root of 2 in our denominator, so I'm going to multiply the top and the bottom by the square root of 2, okay? And we learned this from the last section, that if I do cosine of 45 degrees, then this is going to give me the square root of 2 up top divided by 2 on the bottom. Okay, square root of 2 times the square root of 2 is just going to give me 2. So I have this number for cosine of 45 degrees as the square root of 2 over 2. Okay, this would be something you want to remember because it's going to come back later. All right, now let's do the same thing for sine. Okay, if I do sine of this 45-degree angle, okay, now check out what I get. If I do sine of 45 degrees, now remember sine is the opposite side divided by the hypotenuse, so it's going to give me x over x times the square root of 2, which we've already done. Okay, that's what we had up here for cosine. So in this case, sine and cosine are going to give you the same thing. So sine of 45 degrees, before we do all that math, I don't want to do it all over again, is going to give me the square root of 2 over 2. And that's it. Okay? Now, the one thing I want to do real quick is I want to write out what tangent is. So if I write out what tangent is, tangent of 45 degrees is equal to, so given this, that's my opposite side divided by my adjacent side, that's just going to give me x over x. So here I have tangent of 45 degrees is going to equal 1. Okay? And that's going to be pretty powerful for us later on. Okay? So, you know, I would remember these. Okay? These are ones that you want to remember. All right? You want to come back to. All right? Later on in this chapter. Okay. Let's go ahead and determine the sine, cosine, and tangent ratios for angle L. So what I want to do is come over here and I have a right triangle, okay? We're going to be looking at angle L. I don't know what angle L is, all right? I don't know what that angle measure is just yet. But what I want to figure out real quick is I know that this length is 10, I know this length is 26, but I don't know what this length is here. I'm going to call this x, okay? And so the way I would figure that out, okay, if I have two sides of a right triangle, I have a friend, and his name is Pythagoras. Okay, so what I'm going to do real quick is figure out what x is. So I'm going to take x squared plus 10 squared is equal to 26 squared. I want to say it's going to be 24, but I'm not sure. Okay, so let's do this. X squared plus 100 is equal to 26 squared, which is 676. So this is 676. All right, and so then I'm going to subtract 100 from both sides, and that's going to give me that x squared is equal to 576. So if I take the square root of 576 on my calculator, then that's just going to give me 24. Okay, so if I take the square root of both sides, x is going to equal 24. All right, so this has a length of 24. Now what I want to do is I'm going to do sine, cosine, and tangent for angle L. Now, given angle L, I'm going to write those in. Okay, this is my hypotenuse, this is my opposite side, this is my adjacent side. All right, and so what I want to do here is I'm going to write this out. I'm going to write out sine of L, okay, to be my opposite side divided by my hypotenuse. So that's going to give me 10 over 26, which simplifies down to 5/13. Okay, if I did cosine of angle L, okay, then I write out my adjacent side divided by my hypotenuse. So that's going to be 24 divided by 26, which is going to simplify down to 12 over 13. Okay, and then if I did tangent of angle L, that's going to be my opposite side divided by my adjacent side. So that's going to give me 10 divided by 24. So then that simplifies down to 5 over 12. And that's all I'm doing. Okay? So I know, guys, it's a lot, when you know how to do it, it's really easy. But what we're dealing with is just a lot of new stuff. Okay? New way of thinking, new way of writing things down, and it's kind of confusing. Okay? So bear with me. I know it's hard, but I believe in you, believe in yourselves. We will achieve. Okay, so that's all I have for this. So the whole point of this is your ability to be able to do this. Okay, given sides given a triangle. Okay, write out your ratios. Okay, in the next section, what we'll do is we'll use SOHCAHTOA to solve for sides and angles of a right triangle. Okay, hope you enjoyed this. It's going to get really fun. I guarantee it.